Okay, momentum is mass times velocity, and it's symbolized by the mass in kilograms and the velocity in meters per second. And there's nothing shortcut about that. It's just kilograms times mass over seconds. Now, you could also do Newton seconds, and you can look at those on your own. Thinking about momentum, a semi-truck moving slowly could have less momentum than a hailstone falling a great distance going very fast. It's both things. So just a quick thing here. If I had a 2,250 kilogram truck going at 25 meters per second, that's the momentum of the truck. Now, if we want the car to have that same momentum, it's going to have to be going at a certain velocity to get that, and it's going to have to go faster. And so it would have to go 47 meters per second. Now, momentum is a direct result of Newton's second law of force is equal to mass times acceleration. I'm going to take a look at that the next slide here. And what's going to happen is we're going to have force is equal to mass times acceleration. And in the place of acceleration, I'm going to put velocity over time. It should actually be a change in velocity over time. I'm then going to multiply both sides of the equation by time. And what's going to happen is I'm going to get what's called impulse. And you have to keep in mind that that is what impulse is force times time. So it may take a few times just to remind yourself what is impulse. That's what it is. This is momentum, and specifically it's going to be the change in momentum. So if you remember, force is equal to mass times acceleration. If I want to accelerate something, I have to apply a force. More specifically, in the same sense, to get an object's momentum to change, I'm going to apply an impulse, and this is a direct result of this force is equal to mass times acceleration. Really what's happening is the greater the time you apply a force, the greater the change in momentum. So I apply the force, I apply it over a long time, I change an object's momentum. Okay, so from the video that we watched, the car that crashes, let's take an example of the car crash, okay? This is a set quantity because you have a certain mass of the car, it has a certain velocity, and it's going to stop. And so no matter, how you stop, you're going to stop. So it could be in a car crash, it could be a slow braking, but this is a set quantity. This whole thing right here, a set quantity, momentum is set. Now, because it equals impulse, impulse is set. And you're going to have to write about that in your test, the essay. Now, what can change, though, is the time. The time can change. If I up the time of stoppage, I lower the force. The force is lowered. So I have a car, and it's going to hit a wall. Well, safety engineers try to have this crumple zone, pretty good crumpling time, because the more I can increase the time of stopping, I decrease the force. If the time of stopping is a very sudden stop, the force can be very high. So make sure you got that for the essay question. Okay, they also did an egg one, the egg being, hitting a sheet or a wall. The sheet lets that stopping time go way up and the force goes way down, the egg doesn't break. But if it hits a wall, the stopping time is very short. Force is very high and it cracks. Just a couple of them. I'm going to show you how you're going to do it because this is based on direction. So I've got force times time is equal to mass times the change in velocity or the change in momentum. All right, so we're wondering about the force here. We've got a stopping time of 1 millisecond or 0.001 seconds. We're going to go final minus initial. So I'm going to put 0.036 kilograms. The final velocity is a negative 42 meters per second because I'm returning. So if I'm going to the right at 35, I'm going to the left at negative 40, so it'll be negative 42. So final momentum minus initial momentum, and the initial momentum, is 35. Okay, and so when we calculate that, the force is going to be negative 2,772 newtons of force on the ball by the bat. Now, of course, there's going to be a positive 2,772 newtons of force on the ball to the bat, right? Equal and opposite forces. Okay, this one right here, if I just go ahead and do some kinematics, it will, from a height of 2.7, it'll hit the floor at -7 meters per second. If it rebounds to 0.9, the upward velocity must be 4.2 meters per second. And those are just our old kinematics. V is equal to the square root of 2ay. All right, so doing the problem here, I am being asked for the impulse now, so be really careful here. We are being asked for the entire thing. So I'm going to take the, hey Phil, Phil, I'm doing a video. Can you let the dog out? Phil, I'm doing a video for, oh my God. That'd be my dumb husband. Okay, so I'm going to take the mass. My final velocity is a positive 4.2, and my initial velocity is a -7. So I did that a little bit different. So then the impulse is going to be 22.4 Newton seconds. And I should have maybe used kilograms meters per second, but that's the force. Okay, and that is to the ball by the floor. If you wanted to go from the ball to the floor, it'd be a -22.4. Okay, just some examples. If I want to increase momentum, hit it hard, but also follow through. Get that force up there, get that time up there. We've increased the impulse, we're going to increase the momentum. So any coach will tell you, yes, hit the baseball hard, but follow it through. Long-range cannons, long time, that force acting over a longer time period and gives a greater momentum. If I want to decrease the force, for instance, a car crash, you really don't need a physics degree to figure out that if you had to choose between a haystack and a brick wall, you're going to choose the haystack. But in a physics sense, the reason you're choosing the haystack is your momentum is set, your impulse is set, but you can increase the time, and if you increase the time, you can decrease the force. Okay, some other examples. You're not going to jump from a high area to the ground and lock your knees. You're going to bend them because that's going to increase your stopping time and decrease the force. A boxer doesn't just stand there. If they hit, they roll with the punch, again, trying to decrease that force. And here's some examples. Wood floor, concrete floor, catching a baseball. Anytime you can increase the stopping time, you decrease the force because the impulse is set, because the change in momentum is set. If we want to increase the force, obviously with the sports example, a karate example, hard force, obviously like that. Hit it hard, but hit it quick, okay? So if you want to do something like that, you're going to have a hard, giant force to, and you want to have a really short time. And so you're going to get that. Okay, the other thing we want to do if you're a karate person, you want to hit the board, is to bounce. And bouncing gives two impulses. And people have kind of hard time with that because they say, well, if you're hitting something toward a wall and then it's bouncing back, how is it that you're getting an impulse back? But I'm going to give you a couple of examples that maybe will help you try and understand it. Water wheels used in gold mining operations were curved. So the water would come in, it would curve around, and would come back out, and you get double the force. Let's give an example, a mathematical example here, or let me give you another rolling chair example. So if you were sitting in a rolling chair or a skateboard or something like that, and somebody threw a heavy ball at you, you know you'd catch it, you'd roll back a little bit. Now, if you were to then throw it back at them, you'd roll back even more. So you're rolling back each time because you're double the force on you. So let me just give you an example of a clay ball hitting a wall and stopping, just splat, okay? And let's say that it is going at 5 meters per second, and it's going to stop. And let's say that it's in contact, during the stopping time, the hitting time, it's 0.001 second, okay? And let's say that we have the hard ball, and its initial velocity is also going to be 5 meters per second, but because it's hard, it's going to bounce. it's going to rebound at a negative 4 meters per second, and let's say that it is also in contact with the wall for 0.001 second. This is stopping up against the wall, stopping time, but this is at contact time with the wall. Okay, so if we look at the clay one, let's do the clay one first. I'll just say C. The force is going to equal the final velocity minus the initial velocity over the time. And you'll get negative 5,000 newtons of force. Okay? Now, let's do the hard one. And this time, you can see the calculation is going to lead to a bigger number, because for the hard ball, the force is going to equal the final velocity minus the initial velocity over the time. And we're going to see negative 9,000 newtons of force. So you can show that mathematically or just through a pictorial or an example. I think that's it.